Algae, and in particular microalgae, are some of the most promising and auspicious candidates for alternative energy. To just give you an idea of the amount of potential algal biofuels have, let's consider this statistic which compares algal biofuels to traditional land plant biofuels. Palm trees, which are the current leader in biofuel production, are able to produce on average 635 gallons of biofuel per year per acre, which is relatively respectable. But now let's compare that to certain strains of microalgae, which are reasonably estimated to produce between 5,000 to 15,000 gallons of biofuel per year per acre. The two challenges currently preventing algal biofuels from entering the economic market are, first of all, growing algae effectively. While algae have the potential to grow at phenomenal rates, they can only do this under a very narrow set of conditions. This was the challenge that I focused on my previous 2 years of research. Once we have figured out the optimal conditions for growing microalgae, the second challenge will be how to extract the lipids from the microalgae in the most effective manner. This is the challenge that I focused on in this year's research. For my experiment, I began by first batch culturing my algae for around 1 month. After that, I proceeded to apply 6 different lipid extraction methods on my Cynodesma species, which was the algae I was working with. Through my research, I was able to discover and conclude that the optimal method of extracting lipids from algae is through the use of DMSO methanol solvent, facilitated by ultrasonication. I was able to conclude that this method was around 2 times more effective in extracting lipids than other methods.